Hey, Matt.
Hi, Gigi. Hi, Jillian.
How's it going? Welcome.
Not too bad. It's Friday and the sun's shining, so I'm kind of excited.
Yeah, where are you coming in from today?
I'm on the West Coast. I'm in Oregon.
Oh, it's a sunny day in Oregon.
Yeah, we've had some rain, but it's going to be a nice weekend, and it's kind of the end of spring break, so everybody's kind of excited and out and about.
Oh, very nice.
Yeah, we've got anyone in Oregon, say hi in the chat.
Any West Coasters?
That's right.
Any Pacific Northwesters, any West Coasters. We want to know where everyone's coming in from today. This will be fun. So you are here to hang out with us, but you're also here to talk about some new launches that have happened from AWS Batch. Could you give us a rundown first of what AWS Batch is and what the general use case is for it?
Yeah, AWS Batch is it's a queuing and orchestration tool for running jobs in AWS Cloud, where you don't have to worry too much about the individual compute instances, for example, that you're running each job on. You kind of create a compute environment, which you can think of as like a compute pool that auto scales up and down for you according to how you specify you want it, from a minimum to maximum, et cetera. And then you create a job definition that's kind of a template for each job, and then you can run hundreds or thousands of those jobs, and we handle the queuing of the jobs and the scaling of the compute for you.
I love it. And this has been around for a while, but there's a specific launch that you wanted to talk about. So maybe you can explain the multi-container launch.
Yeah, so this is new, just released a couple weeks ago, and it's really exciting. We are now supporting, so if you're familiar with running jobs or things in the cloud, typically you're going to build your software into a container, which makes it easily portable, deployable into the cloud. But prior to now, you could run one container at a time per job. Now you can run up to 10 containers at a time. And you may go, well, why do I need 10 containers? Why do I care? Well, so for a lot of use cases that we deal with, there's a lot of components that are being run simultaneously within a container. And especially with like autonomous vehicles or robotics, where there's like vision processing, actuation, and control and planning that are all happening. Can you guys hear the train going by? Good timing. Right as I'm talking. Anyway, that's not a robot train, not yet, but maybe in a few years that'll be autonomous. Anyway, as I was saying, so there's a lot of components that need to be run, and previously you had to build everything into one container, which means long build times. You have a lot of stuff that has to be built in there. It means really big containers, and it can basically slow down your development cycle if every time you want to run tests in jobs, you have to do these long builds. So this allows you to split things out into smaller components, like one per container type of a thing, or group them into containers, which is much more logical. That's how we build software anyway, is kind of more at component level, and then subsystems. So yeah, with Batch, you can now have multiple containers so that you can better componentize your jobs.
Got it. So it's like a bunch of shoe boxes instead of one big container that you put everything in the basement.
Yeah. Instead of a giant crate, now you can have much smaller little cube size
with labels.
Yes. And we joke about it, but it's really common that in a large software project, you're going to have different teams working on different components, right? And they're going to potentially even have some slightly different build tools and build cycles, et cetera. And this allows them to independently be doing their work and building their output into a single container, and then those containers are run in parallel, rather than everybody having this giant merge flow where everything has to be merged into one container at the end. Does that make sense?
Yeah, that makes sense to me. Could you give a real life example of some customers that are doing this today? Maybe not their names.
Yeah. So we're working with a few different customers and partners that are in the AV/ADAS space. So that's autonomous vehicles, if you know that acronym, but and also robotics, where they're building autonomy stacks for their vehicles. Like I mentioned, you'll have like perception, control, planning. So we're going to have one of our customers come on air here in a few minutes and give a demo of their simulator that they run along with up to 6 autonomous vehicles in the same simulation at once.
Perfect. I think maybe it's time, Jillian, to bring our additional
Let's do it.
Yeah.
Let's do it.
Let's do it. I think, why don't we get going? Hey,
Hello.
How's it going?
Hey. Fine, thanks. Thanks for inviting me to the show.
Thanks for joining us. We really appreciate it. Do you want to give a little intro and tell us where you're chiming in from today?
I'm joining from Warsaw. I work for a company called Robotec.ai. We are a Polish company working mostly in robotic simulations. So we simulate many different things. Like today, I will talk a bit about mining, autonomous mining simulations. But we do also agriculture simulations, warehouses, spaceships, everything you can imagine.
Even spaceships. That's so
cool. Of course. We can simulate everything you need.
Oh, that's awesome.
And but like Matt started to say, we have some use cases where we really need multi-containers. Today I will show example with that we need to simulate multiple vehicles at the same time with pretty complex system, actually.
Yeah, I want to hear about that a little more because we just learned about what AWS Batch is. We just learned about what multi-container is. So maybe you can tell us about how it is that you're actually using multi-container in AWS Batch.
Okay, I think I can show live demonstration or at least try to.
Let's do it.
That would be awesome. Yeah. Better to see it to believe it.
Okay, can you see my screen already?
Yes.
Okay, cool. So here is a UI of our simulation platform called RoSi. As I said, it supports multiple domains, but I will show our sample that's about mining automation. So here is what we usually start with. So we need to configure experiments with multiple vehicles. This is a top view of the mine. So for our customers, we just set in this configuration view, we set initial states of each autonomous machines that is driving. We also have another layers of configuration because, as you can probably imagine, autonomous mining is pretty complex. It's system of systems. We have a lot of things happening here. We have traffic management systems, site management systems, additional localization systems. Also, safety is very important. We need to configure external traffic in here, but I will not do all of it because it's like maybe it's not super interesting. But what we do then, I have prepared a collection for mining testing, and we have multiple layers of experiments. So and every layer or every system is configured separately.
Do you mind zooming in just like a little bit more?
Okay, let me try.
Yeah. Okay. There we go. Thank you.
Thank you.
Okay. So here comes the magic of the cloud, because if we select multiple configurations here, for example, first one is about initial states of autonomous machines, then we generate all combinations of each layer, and so we can very easily scale up to thousands of experiments, and we can run all of them in the cloud at the same time. I have prepared a collection with one experiment, but okay, let's go crazy and try 3 at the same time. And I will select cloud deployment. And also here we can select a simulation engine that we want to use. We'll go for Open3D engine. It's a very cool open source simulation engine that we as Robotec are working on together with AWS. This is open source, it's perfectly integrated with robotics. It's prepared for robotic simulation. So I really recommend you to try. And then I click start. And what is happening now, maybe I'll just go to the architecture now. So what happened here is our UI was connected to something we call Simulation Manager. And in here, we just combine all the configurations. We then interpret them. So we create job definitions for each of the experiments, and we just send a message like submit multi-container jobs to AWS Batch.
Oh,
Then AWS creates, like, starts multiple instances, one instance per experiment for us. And then what we have is we have a main container with simulator, and we have separate containers for each system in the loop. So each software that we want to test in this simulation.
got it.
And what we can see here, if we go to the AWS Batch console, we can see, or we can already see the experiments that are starting, and we can see that we have multiple containers in here. So simulation container and one container per each autonomous driving system controlling the vehicle.
That's
And
awesome.
I'm curious, because going back to that architecture diagram where you showed us that you have each different containers for each of these vehicles, then are there any additional customizations you're doing within AWS Batch per container?
Yeah, actually, when we submit multi-container job definition, based on what we know from configuration files, we slightly change the parameters for each of the controller. So it can be configured from your code. So you can check, and you can of course also run different systems for different vehicle. That's also pretty cool.
Very cool.
Yeah.
This is a great way to understand the new feature. I feel like it really helps. I said shoe boxes. This architecture diagram makes it make a lot more sense. And you break it up. Are you copying and pasting and just gently, or I guess like minorly editing each container for each vehicle? Or
yeah, that's usually a case. Yeah, we are using the same image, like Docker image, and just configuring it in a bit different way. If we want to test as the same like the same version of controller, we can also test different ones. But then we need to use different container images.
Got it.
Super cool. And
we also
go ahead.
We also have a video, because now that's probably also important part, but because when we are running jobs in AWS Batch, we are running them headless, so without any visualization. We also prepared a video showing how it looks with the visualization.
Oh, great.
This is the really cool part.
Yeah.
I love the term headless because I imagine a bunch of like headless little bodies in these cars driving around. It makes me think that there are people. They're just
the cars drive themselves, so that's kind of true. Like there's no bodies at all. Actually, it's bodiless too.
Oh, we've got a really good question in the chat. So Ciara Playing Games wants to know, how do these containers sync between themselves? Is there something like a Kubernetes empty directory, or how does it compare to Kubernetes jobs?
From our perspective, we just start a job. So we have like a local network, and each container is completely separate, but it's like it's a control system. So it can, and we have a communication between data coming from the simulation and then control messages going back to this from the simulation. So we don't like synchronize them, but they all work real time with the data generated from the simulation in the real time. I'm not sure if it's answered to your question, but
really cool.
Yeah, it was so cool. I really enjoyed the back half of that video too, with the farming visualization. Makes it, I think, understanding how this is useful in so many different contexts. I know, Jillian, you mentioned like in the research medical field in the beginning of this live session that we're doing, but also, you know, if you think about farming equipment, if you think about even how Amazon warehouses are deciding where to put things, all of that is done with simulations ahead of time, right? And to learn and to figure out what to do in the real life scenarios. It's so much fun to watch, honestly.
Yeah, simulation is really critical to developing autonomous robots or vehicles. And yeah, as the Robotec video just showed, you know, the applications for those are just growing all the time, right? So everything from indoor home robots to external, robots that are doing farming, like he showed. You could even simulate spaceships that take robots to the moon, and and robots on the moon. So
yeah, I'm curious. Are you guys ever going to partner with Lego to have little Lego people in the robots?
Feature
Not
request, right?
Thought about it before, but
I don't know. It could be a partnership.
Yeah.
yeah, why
So
not?
if you're watching, this is a missed opportunity to have cute little yellow plastic people hanging out.
I know we're almost at time. So I've got one last question for you, and then we'll one last question for Matt on Batch. So we've got some people in the audience who are very experienced with Batch, but they haven't used multi-container. So I'm curious, from your experience, now that you've gone through and actually started using multi-container Batch, do you have any advice for the listeners here who want to start using it based on your experience?
Actually, if you worked with single containers or classical batch, the transition is very easy. So there's just a different job definition into create a list of containers that you want to run, but it's quite simple. I would say it's not, from developer perspective, it's not difficult to switch.
Cool.
Got it. That's good to know. And I think we have one last question that we should bring up before we wrap. Jillian, you have.
I think, Matt, this would be a question for you. Are there any simulations, any templates or something related to AWS Batch for the life sciences industry?
No, not templates per se, but we do have some blogs that talk about doing some chemical and biological simulations. That's not my area of depth, but if you go to our blog channel, our HPC blog channel, you'll see that there's quite a few blogs on applications of AWS Batch, and I think you'll find some interesting ones there that meet your needs.
Yeah,
Awesome.
and then check out AWS Health Omics. They also have some ready to run workflows that are specific to a lot of life sciences use cases that might be able to help you out.
Great call out. That's really helpful.
Yeah.
Awesome. Well, thank you guys so much. We really
Thanks.
appreciate it. This was so
Thanks
cool.
for having us. Yeah, this was fun. Thank you very much.